After the energy transition, renewable energy sources will make up most of our energy generation. Therefore, it is important that we understand the economics of these energy systems and how to understand what impacts the cost of these systems. The learning objectives for today are to understand the economics of renewable energy technologies. Thereby, we will focus on wind and solar energy. You will gain insight into how these different technologies can be implemented in the energy system and what will be the impacts of the economics on it. Renewable energy generation sources have several major advantages. First of all, they are carbon-free. Wind and solar energy do not depend on any carbon source. So in principle, there is no depletion of carbon resources. As there is no carbon consumption, there are also no carbon dioxide emissions. This will help to alleviate the carbon imprint on society. It will help to prevent any further damaging effects of climate change. Finally, because it is a renewable resource, it is a major step towards a circular economy. A circular economy is an economy in which we do not consume the resources from the earth. Instead, we can use and reuse the same energy source many times. This is possible because the energy does not come from the earth, but instead from the sun. These benefits, however, are typically not yet fully internalized in the economics. But these are major reasons why renewable energy sources are so essential for the energy transition. In general, the economics of renewable energy sources can be defined by the cost and the benefits of a system. The cost includes the capex, opex and fuels cost, and the benefits are created by the energy produced by the system. These can be combined into a single metric through the levelized cost of electricity, the LCOE. Let's take a closer look at a specific case, solar energy. The LCOE of solar energy can be impacted by many things. Firstly, the environment is important. In this case, it concerns the availability of the sun to provide solar insolation. However, other factors can also impact the electricity production. These include the orientation or tilt of the solar panels, shading from buildings or trees, or dust gathering on the panels. These things can greatly affect the capacity factor of a solar park, and so the amount of solar energy generated. All this must be considered when determining the LCOE of the solar system. Additionally, the geographical location needs to be considered. Depending on where you are in the world, a solar panel can receive different levels of insolation. And there are different numbers of daylight hours. This also affects the capacity factor. Typically, the LCOE of solar energy is lower the closer you are to the equator, as there the sun is stronger throughout the year. The weather is typically sunnier in these places as well. So it is cheaper to build a solar park in the desert in Saudi Arabia than in the Netherlands. When investing in a solar park, one should also look at what factors affect the capital cost. It is important that the generated electricity can be transported to the consumer, for which a network connection is needed. This can cause problems if there is a lack of sufficient network capacity. The electricity needs to be transported to the areas of consumption, which are typically the biggest cities. But in the bigger cities, the cost of land is very high. So the economics for investing in solar parks in those regions are not good. This is why the rural areas are often selected for solar parks. But here the network connection may become more expensive, because the distance to the grid is larger and the network itself may have less capacity available. These are some factors that impact the LCOE of solar energy. But how significant are their impacts? This graph shows us how much the LCOE changes when different factors are altered. We can see that capital costs have the biggest effect. These costs are also related to the network connection or the price of the land. By raising the capital cost by $1,000 per kilowatt, we raise the LCOE with $60 per megawatt hour. Changing the capacity factor can also affect the LCOE. This is mostly influenced by the geographical location of the solar park and its surroundings. By decreasing the capacity factor by 5%, the LCOE increases from $135 to $165 per megawatt hour. It should be noted that the influence on the LCOE can also differ depending on the location and the size of the solar park. Let's do the same analysis for wind. What impacts the LCOE of a wind turbine? Here again we have several issues. Firstly, we have the environmental considerations. Which is the location of the turbine, the amount of wind, possible wind shading by other turbines or buildings, etc. So the average wind speed is very important. Having a higher average wind speed can result in a higher capacity factor. Also, we should consider whether the turbine is onshore or offshore. The construction and maintenance of offshore wind turbines is more expensive than onshore locations. We must also consider issues related to the capital cost of the wind turbine. This includes the size of the wind turbine and thus the capacity of the network connection. Offshore turbines may be located near shore or farther away. The investments in underwater cables to transport the power to the network may be significant. Lastly, support schemes are also important for subsidizing the capital cost of renewable energy. These must be considered as well. So, how much do each of these factors impact the LCOE of wind energy? This slide shows us the same graph as we saw for solar energy, but now for wind energy. We will specifically look at the installation cost, the capacity factor, the discount rate and the operational lifetime. Once again, the capacity factor has a large impact here. As noted before, this capacity factor depends on the average amount of wind available at a given location. Similarly, the installation costs have a large impact on the LCOE. This is where most of the cost for renewable energy systems occur. It should be noted that the discount rate also has a large impact on the LCOE for both solar and wind energy. So we have learned what can impact the LCOE of solar and wind energy. What do you think impacts the LCOE of other renewable sources like hydropower and biomass? Can you make a comparison to these?